Okay, let's see if I can explain this to you. So this first picture is of the drive chain, the primary drive chain. And what I've done is I've marked the top dead center, which you will see on there, and that lines up with this mark here. And it just so happens that two teeth on this gear is about the same, 38 degrees I think it is, 19 teeth, so you can work it out for yourself. Works out to be exactly where the timing mark needs to be. So it's two teeth back from there, so that timing mark will line up with that there. So yeah, so mark your top dead center using whatever method you can to find get your pistons on top dead center. And then two teeth later is where the timing mark needs to be. So I should explain that this system actually uses a single spark going to both spark plugs at the same time. So while one's on the firing stroke, the other one is in between inlet and exhaust. So it actually fires in between, but it doesn't affect anything because the exhaust is actually the main part of it. So it doesn't actually, there's no fuel mix in that because it's still just pushing exhaust out. So it doesn't matter, the spark plug. And it's quite common. It's quite a common system. You could, if you wanted to, put two different ones in there. I'm not sure how you do that, but anyway, that's how I've set up mine. So you might have a different way of finding a top dead center and where the actual spark's going to be set off, but that's the way I've done it. So this is the unit with the points in it that I've taken off. So this left-hand picture here, what you'll see is that it's actually got a little keyway or key in there, which fits in a keyway slot in the magneto. So I haven't taken the magneto off. All I've done is taken the plug ends out of the magneto and the advanced retard lever cable out of there. So this has got to come off. What else do I need to tell you about that? I think this is actually a taper on here, so it actually goes into a taper and the keyway locks it in the right position, and then when you tighten the screw up, it tightens up on the taper. So what I do is take this one out, and then I put this ignition rotor in there, and I've left the links to the website there for you. It actually has two magnets on it, and it also has a taper, but guess what? It's not the same taper. So that was a little bit of a problem. So I actually got mine with a Wuzzle CDI unit, but the Wuzzle CDI unit I couldn't get working, so I used this part of it, but you can still buy this as a spare part as well. All right, so what I ended up having to do, this is a 3D printing file, and you can see here the little keyway in there and the little taper, and I've also got another different taper on the inside which suits that new magnetic rotor, or the magnet rotor. So this part here goes on the outside of the magneto, and just down in here it's actually got a little bit of a step which allows it to locate on that magneto rotor. And this is just the cover that goes over it. This is where the hall sensor goes in. So what I need to explain to you is that a lot of these CDI units, and I'll just show you that now, a lot of these CDI units don't use a hall sensor, which is a sensor that picks up magnetic signals. They use something else, which is called a reluctance something or other, blah, blah, blah. Anyway, I don't know much about that side of it. So it took me a while to work out how to get this to actually fire off with a magnet and a hall sensor. And what I ended up doing is having to experiment with a few different circuits, and I'll show you that in a second. So this one is a really good one. It actually has an adjustment on here, so you can actually adjust the advance and retard to suit the vehicle. Now, I haven't had to play around with that much. I've just used what I've got in there at the moment, which I'll change over in the near future, is just one of these. It's a very cheap one, and it shows you the pinouts on there. And that also, they all have advance and retard on them anyway, so you don't need that lever anymore. So I haven't had to do anything with this as far as the advance retard goes. It just seems to be about right. It's easy to start, and I can still accelerate and top speed, and it doesn't seem to make any difference. So that's been good. But if you wanted to, you can buy one of these, and then you can play around with this adjustment if you want to. It's up to you. Like I said, I am putting one of these on, but I didn't have to play around with that adjustment anyway. But this is a better quality one. Comes with a coil, comes with a spark plug, so you can plug this straight into that coil. Now, what you'll need to do is you'll need to have two of these coils, one for each spark plug. But what I've found is the power that comes out of here, this one goes to the coil. So this, you can actually put two wires, one to each coil from that wire there. I am using two 6-volt Lucas coils, and so I've got them in series. So I've got power going to one, then power going to the other. With those other coils that I just showed you, you might need to put them in parallel. I don't know. So I haven't used those coils, but you can. But you can also use the 6-volt Lucas ones. Right. Now, if you're running a 6-volt system, you'll need to convert that 6-volt to 12 volts. And this little circuit board here, MT3608, just put that into your internet search engine, and it will come up with those. And they're like, you get them like $3 or $4 each, and you usually get a few of them. And then you just put a couple of wires on here, plus minus, going to your battery or whatever, wherever you're getting your power from. And then out of here, V out, negative and plus, you will get a voltage, and you adjust that voltage by this little resistor here. So you can set it to 12 volts or 13 volts even. So you'll need one of those in the circuit. Now, this is the little circuit to trigger that CDI box. So it's pretty simple. I've just put them on a little solder breadboard, and it works fine. Please don't ask me how this works, because I have no bloody idea. I just found it by accident. All right. And if there's some electronics expert out there that can do it better or find some faults with it, then that's fine as well. I have no idea why this works with this transistor not even connected on this leg, but it does. So we've got a transistor here, BC556. We've got a simple little capacitor on there, which there's a dime a dozen, and a 10k resistor. So from the CDI box, so you have a trigger plug on there, you have plus 12 volts, and you have negative earth. Those go to the earth on the hall sensor, which is that one there. This one goes to the trigger, which is that one there, and the plus goes to that one. So that is how you connect the hall sensor to the trigger. And what I suggest is if you connect it all up and then just test it, make sure it works. Okay. What else do I need to tell you about that? The hall sensor. I might just go back to my here. You can't see it very well, but this is where the hall sensor goes, in here. So you've got 3 little grooves for the 3 wires to go through. So that hall sensor actually slides into that little groove in there, which isn't 3D printed. And it needs to go in with the smaller face of the hall sensor into that area. Of your magneto, the rotor then sits in here and in that taper on the other side, and then you put a screw through the rotor and through this into the magneto. So I don't know that you can use the same screw, but something like that. And then you tighten it down, and it will tighten down on that taper and it'll tighten down on the other taper, and it locks in quite nicely. I've used PET for the 3D printed parts, and that is a bit better from a point of view of temperature, so it's not going to melt like PLA will. So you can use anything you like for that plastic if you want, if you know about 3D printing, but I've used PET and it seems to be all right. The sensor needs to go in so that the small face, and you'll see this, they're not rectangular, they're longer on one side and then shorter on the other side. The small face needs to go in against where the magnet comes around. And you'll also need to experiment where the hall sensor goes in. So you can slide it in all the way or all the way out again. And it tends to fire on either one edge of the magnet or the other edge. So you just slide it around, get it to a certain point, turn the motor over by hand once you've got your power on and everything, and it will spark. So you need a spark plug or a spark plug tester or something like that sitting on the motor, all plugged in, and when you turn it over you'll get a spark, and we need to fix it in position once you've got the spark working properly. So how do you get the timing done? Well, what you do is you undo the center screw on that little magnetic rotor in the center. You turn that round because it will come loose on the taper. You set your timing to the timing mark on your sprocket, and then you just turn that little center rotor around until you get a spark. Then you screw that in and lock that into that position, and then obviously you want to turn your motor over or go back, come up to it and see if it sparks in the right spot. If it's not quite in the right spot, you just undo that screw in the center of the magnetic rotor, turn it around a little bit, tighten it back up again. All right. Now I've found that little 3D printed part that I put in there, as long as you make sure you get that little key on the first part into the correct position, and then you can actually adjust that magnetic rotor, tighten it up with a screw, and I've had no problem. As long as it's not touching anywhere, it doesn't seem to move. It locks in quite nicely. So that's sort of how you get your timing. I've probably not explained that very well, but if you have any problems, just let me know and I can do a bit more. But that should be enough to get you out of trouble if you've... Here's a picture of my assembly in place. Please don't worry about the mess that is my pieces of plastic. This is probably about the 3rd or 4th modification I've made to them, so they're not quite looking very well at the moment. But you'll also notice that once I got the timing mark correct, I actually put a mark on the outside ring and the inside ring, so that if it ever did come loose, I could actually realign them and it would actually put the timing correct again. But that was just me. If you need the files for 3D printing, I'll actually put those on Thingiverse. So you can pick them up off Thingiverse, and I'll call it something like CDI for Matchless, or it's actually a K2F Magneto, so I'll put that on there as well. So CDI rotor, I guess, probably call it something like that. Anyway, you should be able to find it. You should be able to find I've given you enough information on the hall sensors, that's all up there, or for the CDI box and the coil and all that sort of thing. If you've got any more questions, let me know. We'll see if we can answer them. Thanks.